All right, hello everyone. In this video, what we're going to talk about is a moment about a point. And let's start by defining what we mean by moment. So a moment we're going to define as any kind of force times a perpendicular distance. So you can see I gave a little example here with this wrench tightening some kind of square nut, and I'm applying a force of 2 newtons at a distance away of 3 meters, and that 3 meters is in this positive x direction. My force is in the positive y direction, so actually this moment would be in the positive z direction. So it's your right hand rule coordinate system. The direction is coming out of the page. We'll talk more about 3D. Right now all we have to worry about is force times perpendicular distance, and in general we'll do counterclockwise as positive and clockwise as being negative. So let's, from that example there, let's calculate the moment about point O. So this moment about point O with a force of 2 newtons times a distance of 0.3 meters is equal to 0.6 Newton meters. So when we talk about these signs on the moments, a positive versus a negative moment, based on this right-hand rule, like I said, if I have a positive distance and a positive force, would give us a positive z direction moment. Or the easier way to remember that is anytime we have a counterclockwise result. So I can see that the wrench would move in a counterclockwise direction. We're going to call that positive, and clockwise we are going to call negative. Now note it does say perpendicular distance, so if I had the exact same case, only that force wasn't perpendicular like this. So if I had this scenario, you can imagine that if I need a force times perpendicular distance, what I can do is take the components of this 2 Newton force, and there would be one in the vertical, one in the horizontal, and of course the one in the vertical would be 2 newtons times the sine of 30 degrees. And if that's the case, then for my moment about point O, it would become 2 newtons sine 30 for that vertical force times this 0.3 meters, and that gives me something like 0.3 Newton meters. In general, if I had to write an equation for this, the way I would put it is I'd say the moment about a point is equal to a force times d, which is the perpendicular distance, or some kind of RF sine theta. Now I usually don't put in a sine or cosine just because I'm always looking at my head and saying, is this a perpendicular distance, or what do I need to do to make it a perpendicular distance? But if you're given an angle from the horizontal and your distance is in the horizontal, or you'll have to use some thought instead of just plugging it in. So let's take a look at an example of how we would do this whole thing. All right, so on this example, what we have is a 300 Newton force that's applied 30 degrees away from the vertical. We have this elbow looking thing, which is 40 degrees up from the horizontal at point O. We are trying to find the total moment about point O. So the way that I chose to do this is I said, well, let's go ahead and take a look at this force and break it into an x and a y component. So if I look at the force, I know that I have some kind of x component and y component. So I could call that px and py. And in this case, I know that the angle from the vertical is 30 degrees. So from that, I get my force in the x direction is equal to 300 times the sine of 30, which gives me 150 newtons. And my force in the y direction, of course, is 300 times the cosine of 30, giving me something like 259.81 newtons. So when I have now I have my force in a perpendicular and horizontal direction, I can also do the same thing with my lever arms. So if I have this 200 millimeter long lever arm between O and A, and if I want to break that into an x and a y component, well, I know that this one is 40 degrees, so it has some kind of distance in the x and distance in the y, and from that dx would be equal to 200 cosine 40 which is 153.21 millimeters. And the distance in the y direction is 200 times the sine of 40, which gives me something like 128.56 millimeters. So that's just a matter of which force am I matching up with which direction. And I can kind of see how that would look, because if I were to draw I'm going to make it a little easier and just draw a line, but a free body diagram of what my situation looks like is I found a force of 150 newtons horizontally and a force vertically of 259.8 newtons. And then if I look at my distances, now this is point O that I'm rotating around. So I have this horizontal distance over here that is 153.21 millimeters. And I have this vertical distance, oh, that's ugly, but what are you going to do? Of 128.56. Didn't give myself any room. Let's go ahead and just move this over a little. All right, that's a little bit better anyways. So what I can see here is that if I'm thinking about what's going on with this point O, and I have this 259.8 Newton force pulling up, well, I can see that its lever arm would be the 153.21. Another way to think of this is you're always going to have your x paired with a y. So your x force with y direction, or your y force with your x direction. And that would, of course, would give you an x times a y would give you your z component, which is what we're after. Then all you have to keep straight is what's going counterclockwise and what's going clockwise. So we're going to sum our moments about point O, which equals the sum of my force times their distances, perpendicular distances. So I have the 259.8 Newton force, it was 81 Newton force, something like that, times this 153.21 millimeters. And I have to determine if that's going to be clockwise or counterclockwise. And if I were to put a pin here at point O and spin it around, I would see that that is a counterclockwise, which we are calling positive. And then I have my other moment, which is my 150 Newton force times its lever arm of 128.56. And same idea, and I have to say, well, if I were to pin it at point O and push it that way, I'd end up with a clockwise or a negative moment. So I'm going to put a negative in here. And keeping my sign straight, I add those two together, and I end up with a total of 20,522 Newton millimeters. And I ended up with a positive number. Because it's positive, I'm actually going to designate what direction that overall moment is, and so the overall moment has to be counterclockwise. So that's it for 2D. I'll have a separate video for 3D with an example. Hope that was helpful, and watch part 2 for the 3D bit. Thanks a lot.